Hi there. Thanks for stopping in. I'm glad you showed up. In our first video, we went over the why, how roll call came into be, what was the driving force. I made the statement that I want you to try it as well. And if you're inclined to do so, in this video, we're going to go over some of the key concepts that you need to understand in order to make video chat application work. My name is Tim, and these are the stories of roll call. Now, I don't want to start with the technicalities right off. What I want to do is warm you to the idea of what each component represents, what it's trying to accomplish, okay? And the first thing that we need to discuss is a socket. A socket is a connection between two electronic devices. I want you to think of it like your telephone, okay? You can't speak with a friend of yours unless you dial their number, they're home, they pick up, they acknowledge, say hello, and once that link is established, then communication can flow freely in both directions without restraint. That's what a socket does. Okay, there's two steps to this next part. The first step is NAT, N-A-T, Network Address Translation, okay? At home, you're dealing with a modem that's supplied to you by your internet service provider. It provides you with a little network in your house that all your devices can talk without going to the outside world. And that modem translates those local addresses to an address that's public facing, that is outside of your small little world. It connects you to the rest of the web, and every household, every neighborhood, every town, they all have different stages of these little networks. This is how we've been able to expand our internet past its reasonable use. I think it was 2011 that we've run out of IP addresses in version 4. Getting a little far ahead of myself there, but we've learned ways to get around some of those restrictions. Network address translation is one of them. Step 2 in that process is a STUN server. Session Traversal Utility for NAT? I'll have to check that later. But what this does is allow your device to find out what its public-facing IP address is. We need that information in order to establish our socket between your device and the device you want to talk to. Think of it like you live in a big apartment building. You just moved in and you're expecting a friend of yours to drop by with $20 that they owe you. But you don't know how it is for them to get that information to you. You have to call the front desk. Okay, I'm expecting some information here. Somebody's sending me a check. How do they address it in order to make sure that that process happens correctly? This is what a STUN server does. And in roll call, we use that to make sure that your interface, your media, is going to get to the right place and that their media is going to get back to you. Okay, after we have that, then we need to establish ICE, Interactive Connectivity Establishment. So what this involves is trying to get a path, trying to discover a path from your computer to the computer that you want to talk to. Whenever you send an Ethernet packet, it always contains the source, where it's coming from, and it contains the end target you want to go to. It contains stuff like the pathways. It contains stuff like the speed, how fast you're going to go. And this ICE uses that information to find out where it is that your device is in relation to the other device that you want to communicate with. How roll call uses this, we start back with the socket. Roll call establishes a socket between your device and our server. It establishes a socket between the next user's device and our server. Then we use the information from the stun servers to trigger this ICE argument between both. It's like two people in the same maze with an overseer at one end. There's a pathway that each of those users cannot get through, but if an overseer, if they can talk to that overseer and they can give information, instruction as to how to get one to the other, then they can talk all on their own without the use of that server. And that's what roll call does. Roll call takes the socket information that you initially have, it takes the stun information that you get, and that does that ICE argument in order to make an offer of each user and have them connect all on their own using roll call servers as a common point of communications. And once that's established, once that ICE, that pathway between both servers are completed, then roll call servers are no longer needed. It talks between one device and another. That way we don't overload our servers with processing your audio, processing your video. We don't want to do that anyway. We're not going to process, record, or try to sell any of your data. We're proud of that. Anyway, in a nutshell, that's the process so far. What if that can't happen? What if those ICE offers and replies, those arguments, are unsuccessful? Sometimes there are security measures in place that prevent that from happening. It's not too uncommon. Well, then the turn server would step in. Traversal using relays around NAT. Okay, so the offer and the reply exchange for the IEC fails. There's still a backup, and this backup is a turn server. It is like a messenger. It accepts the information from you and relays it onto the target, and vice versa. It's a little slower. You may not notice it, but it's the only time that your media may be processed through a server. Normally it's from one PC to another PC or phone or tablet, whatever you're using, but it's the only time that another server may be involved. Roll call does not have its own turn server. We have to rely on someone else, and really, once again, it's just a backup in case your ICE fails. Now, the last ingredient in that recipe is WebRTC, real-time communications. Once your sockets, once your ICEs have been established, once the networks are connected, I should say the devices are connected over that network, WebRTC takes over, and then it is real-time, both ways. Everybody can talk. With multiple users, you need the IEC between every single user that's in the room for us, and they have to establish a network connection to every other one, so that if you're in a room of 6, for example, there's going to be you with 5 other connections, and then there's going to be someone else and they have 5 connections, and so forth and so forth. There's a lot of exchanging going on, and that's what roll call does. In a nutshell, it collects everybody's information, the pathways, how to get to them, it shows them how to talk to one another, and then it steps away, lets the magic happen, and stays in the background without interference. It's like a pair of walkie-talkies, some two-way radios. Once you get them both, or all of them, tuned to the right frequency on the right channel, then everybody's talking with everyone else, and communications can happen freely. So, just like I said, an overview. I hope it helps, get you started, takes away some of the mystery. But now, I'd like to ask for your help once again. If you can go to Roll Call, rollcall.ca, that's with a hyphen in there, and I think I'll explain that hyphen in a later video. Go to rollcall.ca, sign up, see where you can talk. Still need some help with some testing, and we're hoping that you can be a part of that. Then go on over to our Discord server and tell us where in the world you had some success with. We'd like to see how far that can go. Anyway, thanks very much for tuning in. My name is Tim, and these are these are the stories of Roll Call.